Good morning. This is going to be objective 4. We are going to simplify complex fractions, and the definition of a complex fraction is a rational expression, rational meaning fraction, whose numerator and or denominator contains another rational expression. So basically it's a fraction within a fraction. So you're going to have fractions inside fractions, okay? And we're going to learn how to simplify them. So we're going to look at example 1. So everybody understand why this is a complex fraction? We've got fractions, and then if you look at the numerator, there's a fraction, and if you look at the denominator, there's a fraction. So you got little fractions within a bigger fraction. So here's our concept, and if you've had me before, you know this slogan. What do we say about fractions? Ooh, yuck, gross, disgusting, nasty. We don't like fractions, and it looks really, really complicated, but it is not. So what we're going to do is we're going to get rid of our fractions, okay? The fractions that are in the numerator and fractions that are in the denominator. How do we get rid of a fraction? We're going to multiply by a common denominator. So if I'm looking at my fractions and I'm looking at the denominators, so I see a denominator of y, and I would see the denominator of x. So my question is, what is the common denominator of x and y? And I hope that you guessed it. It's going to be xy. So in the numerator, I'm going to multiply by xy. My board's not wanting to write today, I apologize. And in the denominator, I'm going to multiply by xy. Okay? And so when I multiply by xy to this, the y's are going to cancel. This y and this y are going to cancel. So that just leaves you x times x, which is going to be x squared. And when you multiply xy times 1, you get plus xy. Anything times 1 is itself. So notice that we have gotten rid of the fractions in the numerator. Okay? Then if we look to the denominator, I'm going to multiply xy times 1, so that will be xy. And then when I multiply it to this fraction, the x's are going to cancel, so then I will just have y times y, which would be y squared. From here, you're just going to look to see if you can factor, cancel, smush, okay, and to see if anything will cancel out. So when I look at this, like if I look at the numerator, I can factor out an x. So if I take out an x, I'll be left with x plus y. Oops. Sorry again, my board's just not wanting to write. And if I look at the denominator, I can factor out a y. And I would be left with x minus y. Now my question is can anything cancel? No. And so you're going to leave it, I would say you could just go ahead and leave it like this, or you could leave it like the original, like this. I would accept either or. Now what if something could cancel? Then you have to leave it in simplest form. Okay, if something can cancel, you've got to leave it in simplest form. So if we look at example number 2, let's look at our fractions in the numerator and the denominator. I've got a denominator of x, I've got a denominator of y, and a denominator of x. So my question is, what's our common denominator? And all you need is xy again. So I'm going to multiply this by xy, and I'm going to multiply this by xy. And it's okay. The reason why you can multiply by xy over xy, what is xy over xy? Xy over xy is equal to 1. It's the same thing divided by the same thing. It's equal to 1. And so if you look at it, you know, you can times by 1 and it's not going to affect your problem. So that's why we are able to times by xy over xy. Okay, but you're only going to do this to the fraction. You're not going to do this to the x that's over here by itself. So I'm just going to bring this x down for right now. And we're just going to concentrate on simplifying the fraction. So when I multiply xy times 1, I have xy. And when I multiply xy to this, the x's are going to cancel, and so I'm just left with plus 2y. I need to fix my board. Divided by, when I multiply this, the y's are going to cancel, so I'm just left with 3x. And then the x's are going to cancel, and I'm just left with minus 4y. Okay, so now we need to go back, and we need to keep going because this is an addition problem. We're going to have to add these two rational expressions together. Okay, so I've got a denominator of 1 over here. I'm going to draw my blanks. And my common denominator is going to be 3x minus 4y. So my second fraction is not going to change. So I'm just going to bring down the xy plus 2y. Okay. Over here, though, so this one can just be times by 1. And so again, that's just xy plus 2y. But on this side, we're going to have to multiply by 3x minus 4y. So I'm going to distribute, and that's going to make 3x squared minus 4xy. Okay, now we've made common denominators. Now we can add like terms. So if I look at this right here, these are like terms. I can add negative 4xy plus 1xy. So I'm going to have 3x squared minus 3xy plus 2y, all divided by 3x minus 4y. And you can try to simplify this trinomial, but you've got a degree of 2, you got 2 variables in the middle. If this had a y squared on the end of it, we possibly could try to factor it and get the xy in the middle, but this one is not going to factor down, so I would leave it like this. You can't factor any 3's out or any 2's out or any 4's out, so that is how you are going to leave this problem. Okay, so ooh, yuck, gross, disgusting, nasty, fractions. So this one's different because it's got a binomial in the denominator, but I'm going to treat it the same way. I'm still going to multiply by a common denominator. So looks like the common denominator is going to be b minus 1. So I'm going to multiply by b minus 1 to the numerator and the denominator. So what happens when I multiply the b minus 1's to the first fraction? The b minus 1's are going to cancel, and you're just going to be left with a. And then when I multiply b minus 1 times 1, I'm going to be left with b minus 1, because anything times 1 is itself. Then when I multiply it to the denominator, the b minus 1's cancel again, leaving me with b. And you got to be careful on this one because it's a minus. So I'm going to leave for right now, just so you can see, I'm going to leave the negative 1, and I'm going to distribute it out to the b minus 1. You have to be careful. You can't just put minus b minus 1. It's because it's really negative 1, and that negative 1 has to distribute to both. And so that's going to change your sign. So I'm going to have a plus b minus 1, and you can't add those. They're not like terms. And then here I'm going to have b minus b plus 1, because a negative times a negative is a positive. Now I can combine like terms. So my b's on the bottom are going to cancel out. And so then I'm just going to have a plus b minus 1, all divided by 1, but anything divided by 1 is just itself. So it's a plus b minus 1. And that's going to be your final answer. Okay, so I encourage you at this point, I'd love for you to be able to pause the video and try this one on your own and see what happens to it. Okay, try this one on your own, see how far you can get. If you just play it through and you just copy my notes, that's not going to help you. You need to see if you can do this on your own. So please stop the video, try it on your own, and then pick back up with me. So hopefully you've paused the video, and when I look at my denominators in this one, I see a b minus 1 and I see a b. B is a monomial, b minus 1 is a binomial. So you gotta have your monomials, so you gotta have your b, and then you've got to also, so I'm going to times by b, and then I'm also going to times by b minus 1, because one's a monomial, one's a binomial. All right, so when I times it to the first one, the b minus 1s are going to cancel, and so I'm just left with a times b, which would be ab. Okay, on the second one, the b's are going to cancel, so I'm going to be left with a times b minus 1. And I'll distribute that in just a second. Okay. In the denominator, there's no, like this is over 1, so nothing's going to cancel. So really, you can just times a times b, which would just be ab times b minus 1. And someone said, you know, can these all just cancel out? Like, can the AB and the AB cancel, and then the B minus 1s cancel? When do you simplify? You simplify at the end. So I've got to keep working up top. AB, and this is a binomial in the top, plus AB minus A. And I may just leave the denominator, because at the end I'm going to try to factor cancel smush, so I may just leave the denominator in factored form, AB times B minus 1. I mean, you can multiply it out and then try to simplify it again, but you're just going to get back to AB times B minus 1. So 1AB plus 1AB is going to be 2AB minus A over AB times B minus 1. Can anything simplify? I hope you're looking in the numerator, because I see something that can simplify this time. So I can take out an A up top, and I'd be left with 2B minus 1, all divided by AB times B minus 1. And because these are on the outside, and they are monomials, they can cancel. So I believe your final answer is going to be 2 minus 1, all divided by B times B minus 1. And 2B minus 1 and B minus 1 don't cancel, because one has a 2 in front of the B and one doesn't. And if you multiply B times B, somebody said B times B is 2B. No, it's not. B times B would be B squared. And so they are not the same things. And these are binomials, so there is your final answer. Okay, every problem has purpose. So let's talk about this. And I want to refresh your memory back from Algebra 1. What do we know about negative exponents? You cannot have negative exponents. Okay, so let me just go back. You don't need to write this down. Let me just go back to Algebra 1 for 2 seconds. If I have x to the negative 3, you cannot multiply something a negative 3 amount of times. So what do you do with it? And someone, I hope, is saying, put it through the magic mirror, Miss Corns. Yes, that's what we're going to do. We're going to take x to the negative 3, and we're going to move it down through the denominator, and when it goes through the denominator, it becomes positive. And it's not taking the reciprocal. This 1 is still down in the denominator. He's right here, but you just don't need him. And when you take everything out of the numerator, you're left with 1. So it's not like I'm flipping the fractions any way, shape, or form. I'm just taking the negative exponent with its base through the fraction bar, and when it goes through the fraction bar, the rule says it will change signs. So I hope that you remember that. So that's what we're going to do here first. If you have a negative exponent, we need to make them positive. So I need to make this 1 over x to the first, or 1 over x. X to the first is the same thing as x. So 1 over x plus 1 over y squared divided by 1 over x minus 1 over y squared. Okay, so now you should be able to pause the video, try this on your own, and see if you can get the answer. So my common denominator is going to be xy squared because these are just monomials. And what I multiply in the numerator, I must also multiply by in the denominator. This is x y squared. So the x's cancel. I'm going to have y squared. Then the y squareds cancel. And x times 1 is just x. Then in the denominator, the x's cancel. So I'm 1 times y squared. And then the y squareds cancel. So minus 1 times x, which would be minus x. And I think at this point in time, you cannot do anything. You can't factor out a GCF. These don't cancel. It's not like you can take out a negative 1 because they're not complete opposite signs. The y squareds are both positive. The x's are what's changed signs. So if you took a negative 1 out from 1, it would change the y squared and it would change the x, and it's not going to cancel. It's still, you'll have a negative y squared and it's still not going to cancel. So I think you're finished. So sometimes it can simplify and sometimes it can't. All right, so what I'm going to do now, I hope that was good for you for the complex fractions. I do want to take a minute and talk about how to simplify radicals in fractions and how to rationalize denominators. We talked about this on day 1, and this is an Algebra 2 skill, so we're just kind of reviewing. We know that you cannot have a radical in the denominator. You cannot have a radical in the denominator. So if it's a monomial, you're just going to multiply by that square root. So I'm going to multiply by the square root of 5, and what I do to the denominator, I must also do to the numerator. So what's 3 times square root of 5? Now remember, 3 is on the outside, square root of 5 is on the inside. They do not match. Outside with outside, inside with inside. So when you multiply them, you just kind of squish them together. Smush them. So you have 3 square root of 5. And then square root of 5 times square root of 5, I hope that you can tell me that it is just 5. Okay, technically inside times inside would be square root of 25, but we know square root of 25 is just 5. Okay, so basically here's what's happening. Square root of 5 times square root of 5, another way to write this is square root of 5 squared. And I'm going to pick on Gonzalo for like 2 seconds. What happens to the square and the square root? You know what happens? I hope everybody's singing my song. Cancel. And you just get 5. So when you square, when I multiply square root of 5 times square root of 5, the square, when I square root, the square and the square root cancel, and I just get 5. Now my question is, can anything simplify? Like the 5s, could I cancel them out? No. In the numerator, the 5 is under the house. It's on the inside. And then the 5 on the denominator is on the outside. So they do not simplify. So there's your answer. 3 square root of 5 over 5. And everybody says, Miss Horns, I thought we were trying to get rid of the square root of 5. We were trying to get rid of the square root of 5 in the denominator. Did we do that? Yes, we did. And it's okay to have a square root of 5 in the numerator. Just not okay to have a square root of 5 in the denominator. So, almost finished. We're getting close. So, it's different when it's a monomial. So I want to click back to example 6 for just a second. You just had a square root of 5. So when all you have is a monomial, you'll just multiply by that square root. Okay? But now I have a binomial. And you do binomials differently than you do monomials. We're going to multiply by the conjugate. So the conjugate of 1 plus the square root of 2 is 1 minus the square root of 2. Basically, I'm kind of making like a difference of 2 squares here. And what do we know about the difference of 2 squares? Difference of 2 squares, the outer and the inner will cancel. So when I multiply this, first of all, what's 1 times 1 minus square root of 2? You'll just have 1 minus square root of 2. But in the denominator, you need to FOIL it out. Okay, and I hope that you're going to realize that. I mean, this will go quicker if you'll realize that the outer and the inner are going to cancel. But I'm going to do the whole thing for you for the first time. 1 times 1 is 1. 1 times the negative square root of 2 is negative square root of 2. Square root of 2 times 1 is 1, positive 1 times square root of 2. And then square root of 2 times square root of 2, and it's a positive times a negative. So first of all, positive times a negative would be a negative. And square root of 2 times square root of 2 is just 2. Because the square, when you square root, they cancel. Okay, and you just let, I mean, technically if you wanted to multiply square root of 2 times square root of 2 and get square root of 4, and then take square root of 4 and make it 2, that's fine. Okay, and I hope you realize here that these are going to cancel. So in the numerator, I've got 1 minus square root of 2. In the denominator, I've got 1 minus 2, which is negative 1. Okay, and I'll accept it if you leave it like this, but I will also tell you, normally we don't need the negative. Like, let's go ahead and simplify it. Like, 1 divided by negative 1 is going to be negative 1. And then negative square root of 2 divided by negative 1, negative divided by negative is a positive square root of 2. So this is probably a better way to write it. Go ahead and simplify, divide both by negative 1, and get rid of that denominator. Okay, so I would love for you to hit the pause button and try this. This is a binomial, so you're going to have to multiply by the conjugate. What's the conjugate of square root of 5 minus 1? Square root of 5 plus 1. Oops. Square root of 5 plus 1. Okay. So up top, I'm going to distribute 2 times square root of 5, outside times inside. So I'm just going to squish those together. 2 square root of 5. And then 2 times 1 is plus 2. In the denominator, square root of 5 times square root of 5 is just 5. Square root of 5 times 1 is plus 1 times square root of 5, or just plus square root of 5. Negative 1 times square root of 5 is minus square root of 5. And then negative 1 times 1 is minus 1. Outer and the inner will cancel. And if you just need to multiply the first and the last, like if you understand that. Okay, if you don't understand that, then you need to do the whole FOIL and cancel it out. Okay, so we're going to be left with 2 square root of 5 plus 2. And then 5 minus 1 is just going to be 4. Now my question is are you finished? Can anything simplify? And I would say yes, you can take a 2 out up top. Because, or if you wanted to, if it makes more sense to you, you can divide this and then divide this. So the 2 and the 4, like this would be 2 square root of 5 divided by 4 plus 2 divided by 4. They're both being divided by 4. And now you can simplify. This is on the outside, this is on the inside. So you can make this square root of 5 over 2 plus 1/2, 1 over 2. And you can put it back together if you want to, like join it all back together, square root of 5 plus 1 over 2. And that would be the final answer. Or if you wanted to, you could method, and you could factor out a 2. And it's okay to factor out a 2 because they're both on the outside. And now that these are on the outside, you can simplify them. You can make this a 1, make this a 2. So then it would be square root of 5 plus 1 over 2. Different people like to simplify different ways. Okay. All right, let me look at the next one, but I think you may be good, so I may be able to stop. No, we probably need to go ahead and do this one. I think this is your last one. So we got square roots all over the place. We only need to focus on the denominator. That's where you can't have a square root. So I need to multiply by the square root of 5 plus the square root of 3. Multiply by the conjugate. So these are both on the inside now. So this is going to make square root of 10, 2 times 5, because they're both on the inside. And then, oops, typo. It should be square root of 3. Oops. And And so this would be plus the square root of 6. Then square root of 5 times square root of 5 is just 5. Now, let's try this. We know the outer and the inner. This will give you square root of 15. This will give you the negative square root of 15. They're going to cancel. So don't worry about that. Then if you do the last, first of all, negative times a positive is going to be a negative. Square root of 3 times square root of 3 is just 3. So this is going to be square root of 10. And these are not like radicals, so you can't add them. Radicals, they have to match in order for you to add them, divided by 2. And you can't simplify the 2. Someone said, can I make this, can I make this a 5 and this a 1 and this a... No. This is on the outside. These are on the inside. You cannot simplify them, okay? You can only simplify something if everything's on the outside, okay? All right, so not too bad. Almost 26 minutes. So be ready for class tomorrow or whenever we come back from our snow days.